Hey, and welcome back to Mr. Gregorius Math. Today we're taking a look at some non-right triangle trigonometry. I don't know for certain whether this is not a right triangle or not. I just know that I don't see that indication that it is a right triangle. So you would see some sort of indication in the top corner if it was a right triangle, or in the triangle that looks like it's most orthogonal. But in this case, we're going to have to work off the assumption that we don't know whether this is a right triangle or not. So a couple of quick ways to check. And we could use Pythagorean theorem, or we could use right triangle trigonometry to see if any of these ratios make sense. But instead of that, if we're just asked to solve for alpha, we can go ahead and use our sine law. And so the law of sines relates an angle, rather the sine of the angle, to the length of the side across the triangle from it. So we have the sine of some angle to the length across. And that ratio should be the same regardless of which angle you're looking at. So often you see three versions of this: sine A over A equals sine B over B equals sine C over C. But actually it's kind of useless to have all three in most cases, because really we generally are just looking for one of these four things, either an unknown angle like we are in this case, or an unknown side length. So this video will show you how to do it with an unknown angle. So we don't know this angle alpha, but really importantly, we do know an angle pair that oppose one another. So we do know this 49 degrees and this 10 units. So if we happen to know an angle pair, we can use the sine law, because we'll know an angle and a side length that'll make up one side of this proportion. So let's go fill in the details of this based off of the information from this triangle. Now earlier I said our known angle is going to go here, so this will be sine of 49 degrees. And our known side length is going to go here, so this will be 10. Our unknown angle is going to go in for A, so alpha will be A. And our side length that is opposing A will be 5. Now I just have to isolate alpha. So my first step will be to multiply both sides by 5. So I'll have sine of alpha is equal to 5 sine 49 over 10. And now I'm not looking for the sine of alpha, but I'm looking for the measure of alpha altogether. So I'll take the sine inverse of both sides. So I'll have sine inverse of 5 sine 49 all over 10. And I should be able to type this entire expression into my calculator. So let's check and see if I can pull that off. So I have my calculator here. I'm going to press second function sine to bring up my sine inverse. I'll open up a set of brackets because I see brackets there. And in my numerator, I'll type 5 sine 49 divided by 10. And I'll close off my brackets. Hitting equals should give me the right answer, 22.17 degrees. So I believe that's the correct answer for that particular measure. I expect it to be smaller than 49 because this side length is larger than this side length. And the side lengths are usually like in order. The smaller angles are across from the smaller side lengths. So I would expect actually this angle to be obtuse and this side length to be quite large, up to about 15. It won't be 15, but it'll be up to it. So this is how to use the angle first version of sine law to solve for a missing angle. Join us next time when we take a look at another sine law application. Don't forget to hit like, subscribe, and ring that notification bell. I do have, what's the one where you can offer me a cup of coffee? It's called Math Class Every Day. Have a good day, folks.